So 6.4a today. We did skip a couple sections of Mod 6, but that's okay. We are beginning our week of factoring. We're going to do two kinds of factoring today. GCF. What does GCF stand for? Greatest common factor. And then we're going to learn how to factor something that has 4 terms using a method called grouping. Okay. So on tonight's homework, you're going to have some GCF factoring. You're going to have some grouping factoring. You may have some that include both. I can't recall. And then you're going to have just a little bit of practice with the multiply, divide, add, subtract again. Okay? Keep all that fresh. All right, so let's get into this. My first GCF problem. There's my first problem. (65x to the 4th minus 10x to the 2nd plus 10). No, I think I mentioned it, I think I mentioned it on Friday, but what is factoring the opposite of? You know? What did we do on Friday? Multiply, right? Factoring is the exact opposite, starting at the end of the problem and going backwards. GCF specifically is the opposite of distributing. Okay? So if I'm looking at this, I want to see what do all these have in common, because that will tell me what was distributed to all of them. So if I look at just the numbers first, 65, 10, and 10. What's the largest number that all those can be divided by?
5.
So a 5 was most likely distributed to get that as a result. What about the x's? Is there an x in all of them?
No.
So that tells me an x was not distributed, because if it was distributed, it would be on all the terms, right? Okay. So if x was not distributed. So if a 5 was distributed, let's think backwards. 5 times what would give me 65x to the 4th? 13 what? X to the 4th. All right, 5 times what would give me negative 10x squared? Negative 2x squared. And 5 times what would give me 10? Positive 2. Now, what if I could have taken out a bigger number, like 10? If I had taken out the wrong number out front, then I would be able to look here and still see something in common. Do I still see something in common here? 13 and 2, there's nothing in common there, and they don't all have x's. So that's the end of my problem. We are just undistributing what was distributed at first. Okay? Ready for the second problem? Negative 2 nx squared minus 10 nx minus 24 n. So looking at the numbers first, I see a 2, a 10, and a 24. What do I have in common that I could take out?
Negative 2.
Okay, I'm going to start with a 2. I'll get back to that negative 2 that somebody said in just a minute. What about letters? Do they all have an x? They don't all have an x, but they do all have an n, which tells me that an n was distributed. Anything else they have in common? Yes, they all have negative signs, but the fact that they all have negative signs isn't as important as the fact that the leading coefficient has a negative sign. If the leading coefficient has a negative sign, you want to take out a negative. Okay, because if there's any factoring that can be done after this step, and there will be eventually, we want to have a positive leading coefficient. So take out a negative if you can. This one I didn't have to worry about it because the leading coefficient was already positive. All right, so let's see, negative 2n times what gives me negative 2nx squared? Just x squared, right? Negative 2n times what gives me negative 10nx? Positive 5x. And negative 2n times what gives me negative 24n? Positive 12? Okay, looking in my parentheses again, is there anything in common? That means I took out the right thing in front, and that would be my answer. Now we're going to get to a point where this can factor further. Okay, and we'll talk about that some tomorrow. But right now we're just going to stop there. All right, you try this one. 30m to the fourth, m to the second, minus 21m to the second, n to the second, plus 6mn. You try that one. Take out what they have in common. All right, between 30, 21, and 6, what's the biggest number they're all divisible by? 3. Was an m distributed? M to the fourth, m to the second, m, they all have an m. Was anything more than m, like m squared, m to the third, was anything higher than that? What about n? Just a simple n, correct? All right, let's see what's left inside. 3mn times what gives me 30m to the fourth, n to the second? Well, 3 times 10, and then m to the third, n. Yes? Okay. 3mn times what gives me negative 21m squared, n squared? Minus 7mn. And 3mn times what gives me 6mn? In my parentheses, anything in common here? Nope, so I'm good. Okay. All right, one more GCF problem. I'm going to try and trick you a little bit. Bless you. And these are all my GCF problems. Now, number 4, I'm trying to trick you a little bit. What do they have in common? Yeah. How many terms do I have there, by the way? I have 2 terms. 1, 2. And those 2 terms happen to have parentheses in common. Do you see that? So, let's think about this for a minute. If that's what's in common, aren't we taking out what's in common? So I'm going to write that out in front. Unfortunately, I have to write it in parentheses because it's a binomial. So x plus 1 times what gives me 5y? X plus 1. This times what gives me that whole first term? Just a 5y, right? So 5y times x plus 1 could be written like that. X plus 1 times what gives me this? Plus 32. So kind of interesting. These 2 parentheses that match become 1 down here. And then the coefficients of those parentheses end up making the second set of parentheses. That's a process you're going to use every time you use grouping. Okay, any questions on GCF? All right, let's move on now to grouping. Have any of you used grouping factoring before? Maybe, some of you. Okay, so grouping is something we use when we have 4 terms that we need to factor. It's not too difficult, as long as you keep yourself organized. I think that's kind of the number one thing in math. None of it's really, well, there is some stuff that's difficult, that's for sure. But it's always easier if you're able to keep yourself organized as you're writing stuff down. Okay, so when I'm doing actually any kind of factoring problem, not necessarily just grouping, I always have to check to see if there's a GCF I can take out first. That's always going to be your first step. So my first question is there anything that all four of these terms have in common that I could take out? No. All right, so since I have four terms, I'm down to grouping. So here's how grouping works. I'm going to cut my polynomial in half. 2 terms and then 2 terms. I'm going to take the first 2 terms. What do they have in common? 5 and x to the third, right? What would be left inside? 5x to the third times what would be 5x to the fifth? X squared, and then 5x to the third times what would be negative 10x to the third? Minus 2. Okay, that's half my grouping. Now I'm going to take this middle sign, and that actually comes down in my next step. And then I'm going to do the same thing over here. What do these two have in common? 4. What else? What's left inside? 4y times what is 4x squared y? X squared. And 4y times what is negative 8y? Do you notice anything that happened here? What do you notice? That's kind of like what happened up here, right? Yeah? So this is going to show me how I write my answer. So the x squared minus 2 and x squared minus 2, those are going to give me one of my 2 parentheses. And then what's my other parentheses? 5x cubed plus 4y. And that's my answer. By the way, can I check my answer to see if I did this right? How do you undo this to see if you did it right? You just multiply them out. Just multiply this like you would have on last night's homework, and as long as you get that, you did the problem correctly. All right? Couple more here. 3x squared minus 6x minus 5ax plus 10a. Do they have a greatest common factor that I can take out? Nope. Okay. So what do I do if there's no greatest common factor? Cut it in half. What do the first 2 terms have in common? 3 and? Okay. What would be left inside? X minus 2. Then what do? Bring down that middle sign. And what do these 2 terms have in common? 5a. Now, when that middle sign's a negative sign, you have to be a little careful. Negative 5a times what gives me negative 5ax? X. Negative 5a times what gives you positive 10a? Negative 2. Do I have those matching parentheses? Yeah. Sure do. So what's my answer going to be? X minus 2, and the other parentheses will be what? 3x minus 5a. By the way, you can write your answer 3x minus 5a first if you want to, and then the x minus 2. Doesn't matter, as long as your 2 parentheses match mine exactly. Doesn't matter which order you write them in. Okay? Now, if I had a GCF that I could have taken out first, where does that go in my answer? Well, just like up here, it comes in front of the parentheses. If I had a GCF, it would just come in front of the parentheses. Okay? All right, last example we're going to do. 42a to the fourth minus 18a to the third plus 35a minus 15. Why don't you take a minute, see if they have anything in common first, and then move on to the grouping step. Mm-hmm. If there's a common factor, yep. Is there a common factor for all four? What are you thinking is a common factor? Well, the first step I have to see, is there a common factor for all four terms? And if there's not, then we cut it in half and then you do the common factor just for two at a time.
Oh, I have to go like this all four?
Yep. So what do the first two have in common? And a to the third. What's left inside? 7a minus 3. Next, I bring down the plus sign. What do these two terms have in common? 5. What would be left inside? 7a minus 3. Do I have those matching parentheses? Yep. So, in my final answer, one of my parentheses is 7a minus 3. What's my other parentheses? 6a to the third plus 5, and that's what my final answer looks like. Not too bad? All right, happy studying.